So this is lecture 7. In lecture 7 mainly we will discuss lecture 6 problems, okay. And in lecture 6 actually we discussed 3 problems, and in the lecture 6 actually we forgot to explain about the Poll-Zero plot. So I will only explain the Poll-Zero plot, or how to plot the Poll-Zero plot, okay. And all the solutions and how to solve this question we discussed in lecture 6. So if you want to know the more about the problem, just watch lecture 6. After that you can watch lecture 7, okay. In this lecture we will discuss what do you mean by Poll-Zero plot, okay. And so this is a question, we need to find the Z transform and ROC and Poll-Zero plot. So in lecture 6 we got the result like this: x of z is equal to 2z into z minus 5 by 12 divided by z minus 1 by 2 into z minus 1 by 3, and the ROC also we got as modulus of z greater than 1 by 2, okay. And we can plot the ROC like this. For example, the ROC of this particular question is modulus of z greater than 1 by 2, means here you can see that if we equate the denominator part, okay, this is the denominator. If we equate the denominator equal to 0, okay, equal to 0 means you will get z minus 1 by 2 equal to 0 and z minus 1 by 3 equal to 0. So if we equate this, you will get two poles actually. So pole is actually we are indicated by this symbol, the cross symbol. So in the z plane you can mark the pole. So here it is one pole which is at z is equal to 1 by 2, okay, and another pole which is at z is equal to 1 by 3. So we got two poles, okay. And similarly you can equate the numerator, okay, numerator equal to 0. So means you will get 2z equal to 0 and z minus 5 by 12 is equal to 0. So these are known as zeros, okay, and we will indicate this 0 by small circle. So in this question one 0 at z is equal to 0 and another one z is equal to 5 by 12. So you can see that this is 1 0, another one is at z is equal to so this is 1 0 and another one is at z is equal to 5 by 12. So between these two poles, okay. This is all about the Poll-Zero plot, and the ROC of this particular system is given by modulus of z greater than 1 by 2. So this is the pole 1 by 2, and it's greater than 1 by 2 means so outside this circle. So this is the ROC. This region is actually indicating the ROC, okay. It's all about Poll-Zero plot and ROC, okay. Now we'll discuss the next question. Again in this question we need to explain the Poll-Zero plot. The detailed explanation for the detailed explanation you can refer lecture 6, okay. Here the question is x of n is equal to 1 by 3 the whole raised to n into u of n plus 1 by 2 the whole raised to n u of minus n minus n, and this is the transform. We got x of z is equal to minus 1 by 6 z by z minus 1 by 3 into z minus 1 by 2, and the ROC is also given by this equation. So, okay, we got all the solution from the lecture 6. So here again I can do the Poll-Zero plot, okay. So this is the denominator portion, okay, this is the denominator, and you can equate the denominator means z minus 1 by 3 equal to 0 and z minus 1 by 2 equal to 0. So we will get two values. One is z is equal to 1 by 3 and z is equal to 1 by 2, okay. Now I can plot these two values here. So one is z is equal to 1 by 2 and another one is z is equal to 1 by 3. Okay, and if we equate the numerator part, okay, numerator part means there is only one factor, that is z, and you equate z is equal to 0. So this is known as the roots of numerator, okay, is known as 0, and here is 1 0, that is at z is equal to 0. Okay, so we got 1 0 at z is equal to 0 and two poles, one is at 1 by 3, another one is at 1 by 2, and in this case the ROC is indicated between these two values, 1 by 3 and 1 by 2. So this is a circle which is at 1 by 3 and another circle at 1 by 2. Okay, this is one circle. So in between means it's a ring. So I can the ROC like this. So this is the ROC. So this ring is actually indicating the ROC of this particular question. Okay, and we got pole zero float and ROC. Okay, now we'll discuss the practice question. Okay, in the previous case, in lecture 6 already we given around 5 problems. Okay, now we'll discuss the solution. Only the final answer we will discuss. Okay, and here the question is x of n is equal to 2 raised to n into u of n plus 3 into 1 by 2 all raised to n into f n. All these problems are related to linearity property, how we can apply linearity property of Z transform. Okay, so I quickly explain the result. Here you can see that one signal, the signal is 2 raised to n into u of n. Okay, means this portion. Okay, this is one part, and based on the result a raised to n into u of n, which is z by z minus a and modulus of z greater than a. Based on this I can write this transform of this particular portion like this, z by z minus 2, and the ROC I can write modulus of z greater than 2. Okay, and another part is again as a causal signal, so I can write the z transform of this particular portion. Okay, it's like z by z minus 1 by 2, and the ROC is modulus of z greater than 1 by 2. Okay, we got the ROCs of z transform and ROC of the individual part. Now we need to check is there any overlap. So you can see that one pole at z is equal to 2. So here I can indicate 1 at 2 and another pole at 1 by 2, and from the explanation you can see that as it is greater than 2 means you need to construct a circle here at 2 and another circle at 1 by 2. Okay, means one signal is greater than 2, means is greater than 2, so this is, and another signal which is greater than 1 by 2. Okay, so is greater than 1 by 2 means there is an overlapping area. Okay, for both signal ROC overlap when ROC is greater than 2. So I can plot the final ROC like this. This is one pole at 1 by 2 and another one is at 2. So both signal overlap if it is greater than 2. So I can say the ROC of the combined signal. Okay, ROC of the combined signal is modulus of Z greater than 2, and I can write the X of Z like this. Okay, the first signal is Z by Z minus 2, and the second signal 3 into Z by Z minus 1 by 2, and the ROC I can write modulus of Z greater than 2. Okay, it's all about the signal. Okay, and we'll explain the next question. Again, in this particular question, there are two parts, 3 into a signal minus 2 into another signal. So one is a causal signal in this form, another one is the anti-causal signal. So now we can directly write the result. So if you take this portion, okay, I can write the Z transform like this. One important point in this particular question, this factor is minus 1 by 2. Okay, so if A in this particular case is minus 1 by 2, so I can highlight this. This is minus 1 by 2, so K is minus 1 by 2. So you need to substitute Z by Z minus A. So I can write like this. The transform of this particular portion is Z by Z plus 1 by 2. Okay, because A is minus 1 by 2, and the ROC you can write modulus of Z greater than 1 by 2. And the second portion is actually we need to take see, this is minus a raised to n into u of minus n minus 1. So we need to group this minus also. Okay, minus and this much portion. So I can write the Z transform of this particular portion without considering the 2. I can write it becomes Z by Z minus 3. Okay, and the ROC is modulus of Z less than 3, because an anti-causal signal, so ROC will be modulus of Z less than A. So similarly you can write this. And now we need to check the common area. Okay, overlapping area. Is there any overlapping area? So based on this I can mark one, Z is equal to 1 by 2. That is one pole, and see here it is actually minus 2, and if you take the modulus, so I will make it clear. So here the pole is at minus 2, but we take minus 1 by 2. This is general form. We need to write in this way. So one is at 1 by 2, so I can construct a circle at 1 by 2. Okay, and another one is at 3. So if we consider 1 by 2 or minus 1 by 2, the circle will be in the same. So another one is at 3. So we got 2 circle. And important point, the first part is greater than 1 by 2, means outside the circle. Okay, outside the circle with radius 1 by 2. And another portion is less than 3, means inside the circle. Inside the circle, the common area you can see that is again a ring from 1 by 2 to 3. So both signal overlap from 1 by 2 to 3. So I can write the Z transform like this. X of Z is equal to Z by Z plus 1 by 2, and there is a 3 actually. Okay, so you need to multiply with 3, and this minus we already considered. Okay, so now it becomes plus 2 into Z by Z minus 3. Okay, and the ROC you need to consider again. ROC you can plot. You can plot the ROC like this. One pole at 1 by 2 I can mark, one is at 3. Okay, so actually one pole is at minus 1 by 2, not at 1 by 2. Okay, but The ROC I can construct between these two points. So this is the ROC. So ROC I can write between the value 1 by 2 less than modulus of Z less than 3. So this is the ROC. Now I will explain the next question. Here again two part, one is causal, another one is anti-causal. Again, if you consider the first case signal, it's 3 raised to n plus 1. So simply you can write like this. It becomes 3 into 3 raised to n. So that is written as 3 raised to n plus 1 and into u of n. Okay. Now it is almost similar to your causal signal. So now we can write the Z transform of this particular signal. This much portion, it becomes Z by Z minus 3, and the ROC is modulus of Z greater than 3. And the second portion, again you need to take care of this minus sign, okay, minus and this much portion, then only we will get the standard form. So you can write like this. It becomes Z by Z minus 1 by 2, okay, and ROC is modulus of Z less than 1 by 2. Okay. So we got two portions. One is modulus of Z greater than 3, means we need to construct a circle at 3 and it is greater than 3, means outside the circle. And another one is that Z is less than 1 by 2, means I need to indicate one point at 1 by 2 and I need to construct a circle, and it is less than 1 by 2, means inside the circle. So now we can see that there is no common area, okay, or common overlapping area, no overlap. So there is no Z transform. So X of Z does not exist, okay, because there is no overlapping area for this particular signal. One signal is greater than 3 and another one is less than 1 by 2. So there is no common overlapping area. So there is no X of Z, okay. And we will explain next question. And here you can see actually three signals. One is u of n, another is u of minus n minus 1, and del of n also, okay. And I can write the transform of the individual signal. So the first signal is like a causal signal, something in the u of n, but again in place of a, okay, here you can see that 3 e raised to minus 2, okay, a raised to n, something like that. In place of a it is written e raised to minus 2. So you can write the Z transform like this. Z by Z minus, in place of a it is e raised to minus 2, okay, and the modulus ROC is modulus of Z greater than e raised to minus 2. Only thing, in place of a it is given e raised to minus 2. So simply you need to write e raised to minus 2. And the next portion, again you need to consider there is no minus sign, okay. So if you write the transform of this signal, actually in this form minus into, so here it is plus. So again we need to take care of that particular thing, and now we will write that if it is in the minus form, I can write so there is no minus, so I can write Z by Z minus 4. There is no minus sign, so I need to put a minus here. And the modulus of is an anti-causal signal, so modulus of Z less than 4, okay. And this is a transform this particular portion, okay. And now we need to write this transform of 5 into del of n. So del of n is a unit impulse signal, and the transform of impulse signal is 1, and the ROC is all Z. So I can write this transform is equal to 1, and the ROC is all Z. Okay, so we got 3 signals, and now we need to check the ROC of the signal, and we'll take each one. Now we can see that modulus of Z for the last portion, del of n, ROC is all Z, means the entire Z plane you need to consider. Okay, anywhere in this particular plane, okay, all Z. And for the second, you can consider modulus of Z less than 4, means this is a point 4, and you can construct a circle here, and it is less than 4, means inside the circle. Okay, this is the region. And now we need to consider modulus of Z greater than e raised to minus 2. E raised to minus 2 means which is always less than 4, so let it be this particular point, e raised to minus 2, and I need to construct a circle here, and the ROC is greater than modulus of Z, means outside the circle. Now we can see that the three individual signal overlap between e raised to minus 2 less than modulus of Z less than 4. Okay, in this particular region you will get a common overlapping area. If you look at the figure, the yellow, red and the blue, okay, all the signal converge between e raised to minus 2 and 4. So I can write the Z transform like this: x of Z is equal to Z by Z minus e raised to minus 2 plus, sorry, here are 3 also, and here we need to write minus 2 into Z by Z minus 4 plus 5, and the ROC is like this. So I can plot the final ROC like this. So here the value e raised to minus 2, e raised to minus 2, and here it is 4. So I need to construct two circles. One is at e raised to minus 2 and other one is at 4, and this region is known as the ROC. Okay, because Z converge the last portion, the whole Z, but the one signal is less than 4, another one is greater than e raised to minus 2. So common area is given. Okay, this is the ROC. And now we'll discuss next question. And here it is given a shifted version of this impulse signal. X of n is equal to 2 into del of n minus 3 minus 2 of del of n plus 3. So in previous lecture we got the result del of n minus m is equal to Z raised to minus m. Those who want to know about the result, watch the previous lectures. And here it's not impulse, it's a shifted version of impulse. Okay, it's all Z if it is del of n. Now it is slightly different, it's del of n minus 1. So you can write it's del of minus m, and all Z except that Z is equal to 0 if m is greater than 0, and Z is equal to infinity if m less than 0. So I can write the result like this. For this particular signal, Z transform as Z raised to minus 3, and ROC you can write is not all Z, because if this thing, if you write it becomes 1 by Z cube, means if Z is equal to 0, the equation becomes infinity. Okay, so I need to write ROC like this: modulus of is not all Z, modulus of Z greater than 0. Okay, not that Z is equal to 0. Okay, and another portion I can write this again del of n plus 3. So for that I can write is del of del q, and ROC again is a problem. If z is tending to infinity, again this portion z cube is also tending to infinity. So ROC I can say modulus of z less than infinity. So two conditions we need to satisfy. One is modulus of z greater than 0, another one is modulus of z less than infinity. So I can say the ROC is entire z plane, okay. ROC is all z except at two cases, at z is equal to 0 and z is equal to infinity, or in other ways you can say 0 less than modulus of z less than infinity. So that is the ROC, and I can write the final result like this: x of z is equal to 2. Based on the linearity property, I can write 2 is z raised to minus 3 minus 2 into z cube. So if you take 2 outside, it becomes z raised to minus 3 minus z cube, okay. And the ROC is already given, okay. Thank you.